We will continue with the chemical properties of alcohol. So last class we had discussed about alcohols act as nucleophile. When alcohol acts as a nucleophile, the cleavage takes place between oxygen and hydrogen. Then protonated alcohol acts as what? Electrophile. During that, carbon-oxygen bond cleavage takes place. Then alcohol is a Bronsted acid because it can donate a proton. Same way, phenol is also a Bronsted acid because it can donate a proton. Now, when we compare alcohol and water, we have discussed alcohol is a weaker acid than water. Next is alcohol is a Bronsted base. Okay. Why alcohol is a Bronsted base? Because due to the presence of lone pair of electron on oxygen atom. So it can easily accept a proton. Okay. So you'll get. So alcohol is a Bronsted base. Now when you see phenol, phenol is not a Bronsted base. Why? Even though phenol, oxygen is having what? Lone pair of electron. Why phenol is not a Bronsted base? Why? Because the lone pair is involved in conjugation with the pi electron of benzene ring. So oxygen atom gets what charge? Partial positive charge. So that is the reason why phenol is not a Bronsted base. So phenol is not a Bronsted base. Because the lone pair of electron on oxygen is involved in conjugation with the pi electron of benzene ring. So oxygen gets what charge? Positive charge. So phenol is not a Bronsted base, but alcohol is a Bronsted base. Alcohol is an acid. Why alcohol acts as an acid? It's due to the polarity of OH group. Now see here, alcohols are CH2OH. Here polarity of OH bond means the sigma bond shifts towards oxygen atom. So this hydrogen atom can be given as what? A proton. So alcohols behave as an acid due to the polarity of what? OH bond. So alcohol is an acid due to polarity of OH bond. So greater the polarity of OH bond, stronger will be the acid. So alcohols are acid due to the polarity of OH bond. So greater the polarity of OH bond, the acidic character will increase. Now we have three classes of alcohols, that is primary, then secondary and tertiary. Now which will be a stronger acid? When we compare primary, secondary and tertiary, which alcohol will be a stronger acid? Now see here. In case of a primary alcohol, there is one electron releasing group. In case of secondary, how many electron releasing groups are there? 2. And in case of tertiary, how many are there? 3. So, alkyl groups are electron releasing group, or they have which effect? Plus I effect. So, what is happening to the electron density on this? They are giving electron. So, the electron density on the oxygen atom will what? Increase. Here there is one electron releasing group. Here how many are there? 2 electron releasing group, and here how many? 3. So in this case, the 3 electron releasing alkyl group donates electron, and what happens to the electron density on this oxygen? So the electron density on oxygen atom increases. So when the electron density on oxygen atom increases, what happens to the polarity of OH bond? It will decrease. So the polarity of OH bond is less in which alcohol? Tertiary, due to the presence of 3 electron releasing alkyl group. So plus I effect is maximum in tertiary. Then it comes in what? Secondary, which has got how many electron releasing groups? 2. And then comes in what? Primary. So which is the strongest alcohol? Primary alcohol is the strongest alcohol. Then comes secondary and then comes tertiary. And how did we explain? We explain it on the nature of what? Plus I effect of alkyl group. Greater the plus I effect, the electron density on oxygen atom increases and the polarity of what will decrease? The OH bond decreases. When polarity of OH bond decreases, what happens to acidic character? it will decrease. So what is the order of acidic character of alcohols? Primary alcohol greater than secondary alcohol greater than tertiary alcohol. So is it clear? So among the three classes of alcohols, primary alcohol is the strongest acid because the polarity of OH bond is maximum, and tertiary alcohol is the least. Why? Because polarity of OH bond is least. So whenever it comes, give reason why alcohol acts as an acid. Then the answer you'll write is what? It is due to the polarity of OH bond. And when we compare the three classes of alcohols, so primary alcohol is the strongest acid because the polarity of OH bond is maximum. And tertiary alcohol is the weakest. Why? Because polarity of OH bond is least here, less. Polarity, we explain it on the basis of which effect? Plus I effect. Greater the plus I effect, electron density on the oxygen atom increases and therefore polarity of OH bond decreases. Comparison of acidic character of phenol and alcohol. Phenol and alcohol. Okay. Now see here, I'm just writing the reaction. Phenol, when dissolved in water, you get phenoxide ion plus hydronium ion, H3O plus. Now alcohol, dissolved in water, you get alkoxide ion plus H3O plus. Okay. So we are going to compare the acidic character of phenol and alcohol. Now in case of phenol, what is possible? Resonance is possible. Why? Because oxygen is having what? Lone pair of electron. So the lone pair of electron on oxygen atom is involved in conjugation with the pi electron of benzene ring. So you're getting a structure like this. So what will be the next resonance structure? This way it goes. Now due to resonance, the electron density is increasing in which position? Ortho and para position. The next structure. So now in phenol, due to resonance stabilization, oxygen is getting what charge? Positive charge. So what will happen to the polarity of OH bond? The polarity of OH bond increases. So that is one reason why phenol is a strong acid than what? Alcohol. In case of phenol, due to resonance stabilization, that is the lone pair of electron on oxygen is involved in conjugation with the pi electron of benzene ring. So in case of phenol, oxygen atom gets what charge? Positive charge. So what happens to the polarity of OH bond? It will increase. When the polarity of OH bond increases, what will happen to the acidic character? The acidic character will increase. So that is one reason. In case of alcohol, do you see, is resonance possible? In case of alcohol, resonance is not possible. So the polarity of OH bond is not increasing as in case of what? Phenol. So that is the first reason why phenol is a stronger acid than alcohol. That is due to resonance stabilization, the polarity of OH bond increases. Now let us see the phenoxide ion formed. In this case also resonance is possible. Why? Because apart from its lone pair, it's having what? A negative charge. So that negative charge will be involved in what? Resonance. The negative charge is involved in resonance. See how? Now, when you compare the resonance structure of phenol and phenoxide ion is more resonance stabilized. Why is phenoxide ion more resonance stabilized? Can you tell? Why phenol? Comparing phenol, this phenol is also resonance stabilized. Phenoxide ion is also resonance stabilized, but phenoxide ion is more resonance stabilized than what? Phenol. In case of phenol, there is charge separation, but in case of phenoxide ion, there is no charge separation. What do you mean by charge separation? In phenol, there is charge separation, but in phenoxide ion, there is no charge separation. See here, due to resonance, electronegative oxygen is getting what charge here? Positive charge. And less electronegative carbon is getting what charge? Negative charge. That is, this is the meaning of charge separation. That is, in case of phenol, there is charge separation. That is, due to resonance, highly electronegative oxygen is getting positive charge and less electronegative carbon is getting what charge? Negative charge. So, in case of phenoxide ion, there is no charge separation. Why? Because the negative charge is involved in what? Resonance. So, oxygen is having what? Its lone pair of electron with itself. So, when we compare phenol and phenoxide ion is more resonance stabilized because there is no charge separation. In case of phenol, there is charge separation. Charge separation means more electronegative species is getting positive charge and a less electronegative species is getting what charge? Negative charge. So, here carbon is getting negative charge and oxygen is getting what charge? Positive charge. So, see here, I have put what arrow here? Reversible arrow. That means the reaction can go in the forward as well as backward direction. Since phenoxide ion is more resonance stabilized than phenol, the reaction will proceed in which direction? Forward direction. So, when it is going in the forward direction means it will give what? A proton. That means it is a strong acid. So, is it clear? That is, in case of phenol, the lone pair of electron on oxygen atom is involved in conjugation with the pi electron of benzene ring, due to which the polarity of OH bond is increasing. Then when we see phenoxide ion, it can also involve in what? Resonance. So, when we compare the resonance structure of phenol and phenoxide ion, the resonance structure of phenoxide ion is more resonance stabilized than phenol. Why? Because in phenol there is charge separation. In case of phenoxide ion, there is no charge separation. The meaning of charge separation is a less electronegative species gets negative charge and a more electronegative species gets what? Positive charge. Here oxygen is getting positive charge and carbon is getting what charge? Negative charge. But when you see phenoxide ion, you see the negative charge is involved in what? Resonance, and oxygen is having its lone pair with itself. So, the phenoxide ion is more resonance stabilized than what? Phenol. So, the reaction goes in which direction? Forward direction. When it is going in the forward direction means it can easily give a proton. So, that is the reason why phenol is a strong acid. Now, when you take alcohol, it's not resonance stabilized and the alkoxide ion is more stable than alcohol. Already we have discussed alcohol is a weak acid. So, its conjugate base will be what? Strong. So, the alkoxide ion is a strong base. So, it can easily abstract a proton from hydronium ion. So, the reaction will go in which direction? Backward direction. So, is it clear? In case of alcohol, there is no resonance stabilization and we know alcohol is a weak acid. So, its conjugate base is a strong base. So, it can easily abstract a proton from hydronium ion and the reaction will proceed in which direction? Backward direction. So, you get questions in reasoning, give reason why phenol is a stronger acid than alcohol. So, in that case, you have to specify all these things. You have to write both this reaction. Then you have to make the resonance structure of phenol as well as phenoxide ion. And you have to tell, in case of phenol, due to resonance stabilization, oxygen gets what charge? Positive charge, due to which the polarity of OH bond increases. So, that point has to be specified. Then the second one is, phenoxide ion is also resonance stabilized. But when we compare phenol and phenoxide ion is more resonance stabilized. Why? Because there is no charge separation. So, the reaction goes in which direction? Forward direction. That means it can easily give a proton. Then when you see alcohol is neither resonance stabilized nor alkoxide ion is also resonance stabilized. But we know alkoxide ion is a strong base. Why? Because alcohol is weak acid. So, the alkoxide ion can easily abstract a proton from hydronium ion and therefore the reaction proceeds in which direction? Backward direction. So, this much you have to specify clearly for the reason why alcohol is a weaker acid than phenol. Next is effect of acidic character on phenol due to the presence of electron releasing and electron withdrawing group. Now, first we'll see about electron withdrawing group. effect on acidic character of phenol due to the presence of electron withdrawing group. Now see here, I'm making phenol, I'm making orthonitrophenol. Now NO2 is an electron withdrawing group. Now due to resonance, the electron density increases in which position? Ortho and para position. Now NO2 group, it will withdraw this electron. When it is withdrawing the electron, it disperses the negative charge and stabilizes the phenoxide ion So when the stability of phenoxide ion is increasing, what will happen to the acidic character? The acidic character will increase. So acidic character increases. So is it clear? When electron withdrawing group is present, they withdraw the electron and they disperses the negative charge and stabilizes what? Phenoxide ion. So what will happen to the acidic character? This acidic character increases. So that effect is maximum in which positions? Ortho and para position compared to which one? Meta position. Because in meta position, due to resonance, electron density is not increasing. Even then they will withdraw electron, but the intensity is less in which position? Meta position. So if you have orthonitrophenol, paranitrophenol, metanitrophenol and phenol, which will be the strongest acid? Para. Why? In case of para, the groups are coming in what? Opposite direction. So the effect is maximum. So paranitrophenol greater than orthonitrophenol greater than metanitrophenol greater than phenol. So if an electron withdrawing group is present in phenol, it will be a stronger acid than what? Phenol. And that effect is maximum in which position? Para, then comes in ortho and then comes in what? Meta. Why it's in para mode? Why? Because it's coming in which direction? Opposite direction. Because it's having a symmetrical structure. So the ability to withdraw electron is more. So how do they affect it? That is, they are withdrawing electron and dispersing the negative charge, and thus what is happening to the stability of phenoxide ion? Stability of phenoxide ion is increasing. Whenever the stability of phenoxide ion increases, what happens to acidic character? That will increase. So electron withdrawing group increases the acidic character of phenol. More the number of electron withdrawing groups, more stronger will be the acid. Suppose you have this compound 2,4-dinitrophenol. This is a stronger acid than what? 2-nitrophenol. Why? Here there is one electron withdrawing group, but here how many are there? 2. As the number of electron withdrawing group increases in phenol, the acidic character of phenol increases. And you get all this in reasoning. But when you explain the reason, it should be clear, because most of you write what? Why orthonitrophenol is a strong acid? You'll write it is because due to the presence of electron withdrawing group, so it increases the stability of phenol. It is not increasing the stability of phenol. It increases the stability of what? Phenoxide ion. So instead of writing phenoxide ion, if you write phenol, you won't get marks, because stability of phenol is not increasing. The reaction is going in which direction? Forward direction. That means whose stability is increasing? Phenoxide ion stability is increasing. So that is the reason why acidic character is increasing. Now, if an electron releasing group is present, okay? If an electron releasing group is present. Now see here, I am taking 2-methylphenol, okay? Or it's known as what? Orthocresol. Now here CH3 is what type of group? Electron releasing group. So what is happening to the intensity of negative charge? It will increase because these are giving electrons. So what will happen to the electron density on oxygen atom? It is increasing. So what happens to the acidic character? It decreases. That is, electron releasing group intensifies the negative charge and thus destabilizes phenoxide ion, and hence acidic character decreases. So is it clear? Electron releasing group intensifies the negative charge and thus destabilizes phenoxide ion. Here they disperses the negative charge and stabilizes what? Phenoxide ion. That is, the intensity of negative charge is decreased here. Here the intensity of negative charge is what? Increased. So here the stability of phenoxide ion increases. Here the stability is decreasing. So when the stability of phenoxide ion decreases, what happens to the acidic character? The acidic character decreases. So the effect will be maximum in which one? Para, then comes ortho, then comes meta, and then phenol. So what will be the stronger acid? Phenol, then greater than meta, electron releasing group phenol, then comes ortho, electron releasing group phenol, and then comes what? Para, electron releasing group phenol. So is it clear? So electron withdrawing group increases acidic character of phenol and electron releasing group decreases the acidic character of phenol. So phenol is a stronger acid than alcohol because polarity of OH bond is increasing due to resonance stabilization, and phenoxide ion is more resonance stabilized than phenol. So the reaction goes in the forward direction, and neither alcohol nor alkoxide ion is resonance stabilized, and alkoxide ion is a strong base. So it abstracts the proton and the reaction goes in which direction? Backward direction. Now electron withdrawing group increases the acidic character of phenol by dispersing the negative charge and stabilizing the phenoxide ion, and electron releasing group decreases the acidic character by intensifying the negative charge and destabilizing the phenoxide ion. Reaction of alcohol and phenol related to acidic character. Now, since it's an acid, it will react with what? Metals, and they'll liberate what? Hydrogen gas. So, reaction with metals. If you take alcohol, CH3CH2 OH, in react with reactive metals like sodium, you get what? CH3 CH2 ONA plus half H2. So hydrogen gas is liberated. This is known as what? Sodium ethoxide. Now same way phenol also reacts with metals. When treated with sodium, you get sodium phenoxide plus half H2 gas. So this reaction is common both to alcohols and phenol, both are acids. Now reaction with alkali. Reaction with alkali. First I am going to write is of phenol. Phenol reacts with alkali, say sodium hydroxide, and you get sodium phenoxide, ONA, plus what will you get? H2O. Same I am taking ethanol. Ethanol plus NaOH, here no reaction. That is, alcohol being a weak acid, it is not reacting with alkali. What is the reason why it's not reacting with alkali? Because since alcohol is a weak acid, its base, that is, what is the base here? C2H5O minus. Its conjugate base is what? Strong. So it can easily abstract a proton from OH minus. See here, NaOH will dissociate to give you what? Na plus and OH minus. So this ethoxide ion, which is a strong base, it easily abstracts a proton from what? OH minus, and it will be converted back to what? Alcohol. So that is the reason why alcohol does not react with alkali. So it's a main difference between what? Phenol and alcohol. From this reaction itself, we can say that alcohol is a weak acid. It's not reacting with what? Alkali. Because the alkoxide ion formed it easily abstracts a proton from OH minus ion, because the alkoxide ion, that is the conjugate base, is stronger than what? NaOH. So it easily abstracts a proton from OH minus and it's converted back to what? Alcohol. So alcohol does not react with what? Alkali, but phenol is a strong acid, so it easily reacts with what? Alkali to give you sodium phenoxide. So is it clear? So how will you distinguish phenol from alcohol? Phenol turns blue litmus red, but alcohol does not turn blue litmus red. And then phenol, when treated with neutral ferric chloride, you get a violet color precipitate. It's a complex which has got violet color, but alcohol does not react with neutral ferric chloride. Okay. So this is how you can distinguish between alcohol and phenol. Main is litmus test itself. Phenol turns blue litmus red, alcohol does not turn blue litmus red. Then as reaction with neutral ferric chloride, with phenol, neutral ferric chloride gives you a violet color precipitate, and with alcohol, no coloration. That means it's not reacting. Next is esterification reaction. Now, what is esterification reaction? See here, alcohol oblique phenol reacts with acid oblique acid derivatives to give ester. So that reaction is known as what? Esterification reaction. Reaction of alcohol or phenol with acid and its derivatives to give ester is known as esterification reaction. So the first one we'll see here. I'm taking C2H5OH. This is treated with acetic acid. Okay. And the reaction takes place in presence of concentrated sulfuric acid. So always OH will go from the acid and H will go from the alcohol. So what is eliminated? H2O. So what will be the product? CH3, C double bond O, O, C2H5. What is its name? Ethyl acetate. That is its common name. Or IUPAC name will be ethyl ethanoate. So I'll just write it with phenol also. So phenol reacts with CH3, COOH. In presence of acid, you'll get CH3, C double bond O, O, C6H5. This plus H2. This is known as phenyl acetate or phenyl ethanoate. Now here you see in both these cases the group introduced is known as what? Which group is the common? CH3CO. CH3CO group is also known as, it's known as what group? CH3CO is known as acetyl group. It's known as acetyl group. So this esterification reaction can also be called acetylation reaction. When will you call it as acetylation reaction? If the group introduced is acetyl group, then the esterification reaction can be also called as what? Acetylation reaction. Acetylation reaction. Introduction of acetyl group in alcohol oblique phenol is known as acetylation reaction. See, these groups can be introduced. Acetyl group can be introduced in amine also. That will be studying the chapter amines. So in that case also, we'll be calling it as what? Acetylation reaction. That is, introduction of acetyl group in alcohol or phenol is also known as acetylation reaction, because it's also what? Esterification reaction. But the group should be what? CH3CO. Suppose here I am taking, instead of CH3, I am taking C2H5. So what will be the group introduced here? C2H5. So here you can't call it as what? Acetylation reaction. This is what? You will call it as esterification. In case of esterification, It's what? Introduction of what? RC double bond O is introduced, where R can be any alkyl group. When alkyl group is CH3, then we call it as what? Acetylation reaction. So all esterification reaction is not acetylation reaction, but all acetylation reaction is what? Esterification reaction. Is it clear? Now, in case of esterification reaction, you see, what is the arrow here? It's reversible arrow. So, the water formed has to be removed immediately. Otherwise, the reaction will go in which direction? Backward direction. Is it clear? So, during esterification reaction, the water produced has to be removed immediately. Otherwise, the reaction will go in the backward direction. The meaning will continue in the next class.